Hello, this is Mrs. Ward, and I'm going to go over problems that are similar to the homework that you have assigned tonight from section 2.5, implicit differentiation. So what I tried to do is I tried to pull a problem from every type of problem that you're being assigned and talk you through it. If you have any questions on the homework that you're assigned, you know the answer solutions are also posted on top of this page. Any questions, email me or meet me in the collaborative room. All right, the first one, number 4, comes from the set 1 through whatever. Okay, so number 4, it says find dy dx by implicit differentiation. So I'm going to take the derivative of x to the third, which will be 3x squared. Remember, I don't have to write a dx because dx over dx would just be 1. And then I'm going to write plus, and then the derivative of 3 y to the cubed is 3y squared. But now I'm going to say I'm taking the derivative of y in terms of x. And then the derivative of 8 is 0. Solving for dy dx, I'm going to put that on one side by itself. Everything else will go on the other side. So I'm going to have 3x is equal to 3. This will be a negative 3y squared dy dx. Divide both sides by negative 3y squared. And when I do that, I'm going to get a negative x squared over y squared is equal to dy dx. And that's all I have to do for the first set is find the derivative in terms of x. Number 13 is still from the same set. You're still finding the derivative of y in terms of x, but I thought I'd do one with the trig function. So when I take the derivative of sine of x, that's going to be cosine of x. Again, it's the derivative of x is just 1. Don't need to write a dy dx. Here I'm going to have to do the product rule. So I'm going to leave x alone, take the derivative of what's inside the parentheses. So the derivative of 1 is 0. The derivative of tangent is secant squared y. And then the derivative of y would be that dy dx. Plus, and then the derivative of x is 1. And then I'm leaving the second term alone, or the second factor alone, I guess I should say. So when I do this, I'm going to have cosine x is equal to distributing the x. I'm going to have x times secant squared y dy dx plus distributing this 1, this will be 1 plus tangent y. Now solving for the dy dx, I'm going to leave this, the only thing that has the dy dx is this term right here. Everything else doesn't, so I'm going to take this, and it's all going to go over to the other side, so I'm going to do that now. Maybe. So when I do that, I'm going to have cosine x minus 1 minus tangent of y is equal to x times secant squared y dy dx. Solving for dy dx, I'm going to divide both sides by x secant squared y. And when I do that, I'm going to have dy dx is equal to, and I'm just going to leave it as the cosine of x minus 1 minus the tangent of y, all over x times secant squared y. And to be honest, when you're solving for a point or something like that, sometimes you'll make more mistakes if you try and simplify it. As long as you have the dy dx on one side by yourself, you're good. You can stop there. In exercises 17 through 20, you're to find the two explicit functions and solve the equations for y. Sketch the graph of the equation, label the parts given by the corresponding explicit functions. So let's do that first. This is the one we did in our notes when we went through the notes. If you watch notes video, I'm going to do number 20, and then your homework, I believe, is 17. So when I go to do this, I am going to take the derivative, so that'll be 18. Oh no, forgot what I'm doing. I'm going to solve for y. So to solve for y, I'm going to have 9y squared is equal to x squared plus 9. Divide both sides by 9, so y squared is equal to x squared plus 9 over 9. Remember, you cannot simplify those 9s because they're terms, not factors. Taking the square root of both sides, I'm going to have y is equal to plus or minus, because I'm taking the square root. The square root of the numerator will stay underneath that radical sign. As tempting as it might be to make that x plus 3, do not do it. That is not right. And then the derivative, or sorry, the square root of 9 is 3. So that's part A. Those are my two explicit functions, and then it wants me to graph. Well, I like going down memory lane. If I if I go up here, 9y squared minus x squared is equal to 9. I should recognize this from our lovely chapter 10 on conics, that this is a hyperbola. 9 is equal to 1. So if I were to sketch that, remember my center would be 0. There's my lovely family again. My center 0, 0. My y would go up 1. My x go over 3. My vertices are going to be at the y. Make my little box. Remember all this? Man, I wish we were having a final, because then you would have to know all this. So here's my graph that goes like this. So that's my graph. This part, the part that's positive, will be the positive square root of x squared plus 9 over 3. This part down here will be the opposite of the square root of x squared plus 9 over 3. So that's part B, sketching the corresponding. If you pulled out your calculator, know that I'm sad, but that still will get you the right answer. Part C, differentiate the explicit function. So I'm going to go here, and I am going to rewrite the function. So I'm going to rewrite y as plus or minus 1/3 times the quantity of x squared plus 9 to the 1/2 power. All I've done is rewritten that to make it easier for me to take the, because I don't want to use the quotient rule to find the derivative. I just want to use the power rule in the chain rule. So what I'm going to do here is I'm going to say the derivative. Here's that plus or minus 1/3. And then bringing the 1/2 down, so that'll be 1/2 x squared plus 9. Decrease that by 1, so negative 1/2 power. And then the derivative of what's inside will be 2x. So when I simplify this and clean it up, it's still going to be plus or minus. The 2's here will simplify. I'm left with x in the numerator, and then 3 times the square root of x squared plus 9. And that's the derivative explicitly. In other words, I solved for y and took the derivative. Now, part D says find dy dx and show the results. So now for part D, and I guess I'll do that here, I am going to find the derivative up here. So I'm going to say 18y dy dx minus 2x, and then the derivative of 9 is 0. So I am going to have 18y dy dx is equal to 2x. Divide both sides by 18. And I am going to have dy dx is equal to x over 9y. So that's my derivative of y in terms of x. Now, the last part says that they want me to show that this derivative and this derivative are the same. Right now, they don't look the same. This is when I go back and say, well, this is what y is equal to. And I'm going to put that y in for this y here. So when I do that, I will say dy dx is equal to that x is not changing. That 9 will be here. And then in place of this y, I'm going to write plus or minus, and then the square root of x squared plus 9 all over 3, because that's what y is equal. Here, what can simplify is the 3, and the 9 will simplify. So I am going to write dy dx is equal to this plus or minus. I'm just going to bring up on top. So plus or minus x. I will have 3 times the square root of x squared plus 9, which is exactly what I have up here. So they do match. So when it's asking you to verify, you have to show that the one side looks like the other side, and you're probably, or the one derivative looks like the other derivative, and that requires you for usually to substitute in y. Okay, number 24, it says find dy dx by implicit differentiation and then evaluate at a given point. So I'm going to do the same thing I have been doing. I'm going to find the derivative, and then I am going to evaluate at this point -1, 1. So on the left side, I'm going to use the chain rule. And you know, when I looked at the solution manual, it did not use the chain rule. So I'm going to show you, I did the chain rule. So I'm going to do the chain rule, and then I'm going to tell you what they did in the solution manual. So if you're looking at it, you understand what they did. Of course, you probably would never go back and look at 24, but that's what I'm going to do. Chain rule. I'm going to do 3 times x plus y, decrease that by 1. So that's 2. Now I have to take the derivative of what's inside. The derivative of x is just 1. This plus sign is going to stay a plus sign because I'm going to go term by term. The derivative of y will be dy dx is equal to, this will be 3x squared plus 3y squared dy dx. Now, when I do this, I'm going to have to multiply. This is going to have to be distributed to both things in here. So I'm going to have 3 times the quantity of x plus y squared. That's what I get when I multiply it by 1. Plus 3 times the quantity of x plus y squared times dy dx is equal to 3x squared plus 3y squared dy dx. Now, add the two things that have dy dx are this term here and this term here. The things that do not have the dy dx is this term here and this term here. So I'm going to bring all the green stuff here, all the yellow stuff over here, and that's just the way I'm going to do it. So when I hit, so here I'm going to subtract that 3x squared from both sides. So this will be 3, and then I'm going to have x plus y squared minus 3x squared is equal to, and now this 3y squared will be positive because it's staying on the same side, and I'm subtracting this 3 times x plus y squared, and both of these are going to be multiplied by that dy dx, and I hate it when my thing does that. All right, now at this point, I guess at this point, since I'm trying to find the derivative at a point, well, no, I'm not there yet. I'll be quiet. I'm going to divide both sides to find dy dx. dy dx. I'm going to divide both things by that. So I can have 3 times the quantity of x plus y squared minus 3x squared all over 3y squared minus 3 times x plus y squared. So I've just divided. At this point, you could simplify it because the 3x squareds, like here when I square this, this will be 3x squared, and the 3x squareds will equal 0. I could do that. In fact, I did do that, but when I think about it, I want to find the derivative at this point, negative 1, 1. So at this point here, I can just substitute in what I know. So I can say dy dx. So dy dx, x is equal to negative 1, so I can make this 3 times negative 1 plus 1 squared minus 3 times negative 1 squared over 3 times 1 squared minus 3 times negative 1 plus 1 squared. I mean, you got to remember what you're doing. You're trying to find the derivative of the point. I don't necessarily have to have a pretty equation to do that. I just need to know what to substitute my x and my y in. If I do it this way, this is 0, right? So this whole term is gone. This will be 0, so this whole term was gone. Negative 1 squared would be 1, so this will end up being negative 3. I'll write that over here, even though I have 2 equal signs, I'll deal with it. And then this will be over 3, and that my dy dx is just going to equal negative 1. And so the slope of the tangent line at that point is going to be negative 1. And that's what it wants, so that's the way I'm going to do it. What your book did, remember I told you your book did something different. And to be honest, I would have never thought to do this. They just raised this to the third power. Remember Pascal's triangle? Oh, yes, Mrs. Ward. Yeah, so if I do Pascal's triangle, this would have been x to the third plus 3x squared y plus 3xy squared plus y to the third. And then they took the derivative term by term. I don't know if that's easier or harder. I didn't think to do it that way, but I think it's really important that you understood how to take the derivative of this moving forward. So either way is fine. Remember though, your end game is to try and find the derivative at the point. So as soon as you find dy dx, you can try and simplify this if you want, but I say why bother? Just substitute in your points and move on with life. All right, moving on. You're doing the tangent of x. It's the same set of directions. You're doing the tangent of x plus y is equal to x. Now this one, you have to do the chain rule. You can't do it any other way. Please, please, please do not think you can distribute the tangent. You cannot make a tangent x plus tangent y. That's not the way tangents work. So don't even think to do that. I'm sorry if you never thought to do that. Don't do that. Bad idea. So taking the derivative of the tangent, that's going to be secant squared. And then my x is x plus y. That's taking the derivative of tangent. Now to take the derivative of what's inside, the derivative of x is 1. The derivative of y will be dy dx. And then equals, and then the derivative of x is 1. So now I have to use the distributive property. That's an ugly color. So I'm going to multiply this by 1, and I'm going to get secant squared x plus y plus, and now I'm going to multiply it by this. So I'm going to have secant squared x plus y dy dx, and that's equal to 1. Leaving the secant squared on one side by itself, taking these two and putting them together on the other side. To simplify, that's what I'm going to do. So when I do that, I'm going to have secant squared x plus y dy dx is equal to, and then it's going to be 1 minus secant squared x plus y. That's a really hard color for me to see, so I'm going to switch colors. I am going to divide both sides by secant squared x plus y. So divide this by secant squared x plus y. Now, hopefully, again, at this point here, you could just substitute in the ordered pair, which is 0, 0. And you could find the secant of 0 and then square it. Or you could have simplified this. I recognize this as the negative tangent squared x plus y, because that's one of my identities, over secant squared. And then I thought it was tangent is negative sine squared. I don't know if anyone would do the cosine squared. And then secant is 1 over cosine, so this would be cosine squared. So this will all end up equaling negative sine squared. If you didn't do that, that's fine. You're putting in the ordered pair 0, 0. So I'm putting in this ordered pair 0, 0. So I'm either doing it here, and I'm taking, if I didn't simplify it at all, I'm going to have 1 minus secant squared of 0 over, I'm going straight from here, over secant squared of 0. I'm sure you're putting in your calculator. I know you're putting in your calculator. So this will end up being 1. So this is 1 and this is 1. So here I'm going to have 1 minus 1 over 1, and I'm going to get 0. So my derivative is 0. If I would have done here and I would have made negative sine squared, well, the sine squared is 0, the opposite is 0, 0. Either way, you're going to get the same answer. It's just a matter of whether you want to, as soon as you can sub in, you sub in, or if you want to continue simplifying. Again, if you got this far, I'm happy. I'm happy. I'm very happy. All right, moving on. This one, find the famous curves. These are curves that we talked about in chapter 7. Find an equation of the tangent line. So this time we're going to find the full equation of the tangent line. So the first thing we're going to have to do is find the slope of the tangent line at that given point. So I'm going to have to find the derivative of that equation. So when I do that, I'm going to do the left side first. 2 times 3 would be 6. So I'm going to have 6 times x squared plus y squared. Reduce that power by 1, so that'd be raised to first. Derivative of x squared is 2x. Derivative of y squared is 2y dy dx. And that's equal to 100. And then the derivative of x squared is 2x minus the derivative of y squared would be 2y dy dx. Then I am going to, this one on the left side, you have to use the, I'm going to leave the 6 out in front. And I'm going to have to foil those two. I'm trying to decide if I really want to foil those two. I don't think I want to foil those two. I really don't. I think, you know what I'm going to do? Because in order to do this, I would have to foil these two, and I don't think I want to do all that. So what I've decided to do, because I can change my mind in the middle of the problem. Again, I just want to find the slope, so I may go ahead, and this is going to give me grief here, and I might want to just say, well, here I found the derivative. I'm going to leave these as my variables. This here and this here, I'm going to leave as my variables, and then I know my x and my y. My x and my y are 4 and 2, so I'm going to substitute those in. So I'm going to have 6 times, my x is 4, 4 squared plus y 2 squared times 2 times 4 plus 2 times 2 dy dx, and that's equal to 100, and then 2x is 4 minus 2y is 2 dy dx. That's like one side there. So here, this is 16, so this is 20, so this is 6 times 20 times 8 plus 4 dy dx is equal to 2, 8. Well, here, let's go slow. 8. So this will be 8 minus 4 dy dx. So now distributing my 120, I believe that's 120. And I think it's, yeah, I was right. Why do I doubt myself? So this is 960. And I take, I'm thinking this is 120. So 120 times 8, and then 120 times 4 will be plus 480 dy dx is equal to 800 minus 400 dy dx. So the dy dx's I'm going to put on one side by themselves. Everything else will go on the other side. So I am going to bring this over here. I hate when it does that. So this will be 880 dy dx. And then I'm going to take this over to the other side, so that'll be a negative 160. And when I divide by 880, dy dx, I get negative 2/11. So that's my slope. So I'm going to point slope. So y minus 2 is equal to negative 2/11 times x minus 4. So I wonder if I should, y minus 2 is equal to negative 2/11 x plus 8/11. Now subtracting, adding to the both sides, which would be 22. I get 30/11. And there's this, my tangent line. Okay. Oh, don't you hate it when it does that? Okay, last one. I think it's the last one. Find, no, it's not. Find the second derivative in terms of x and y. So when I take the first derivative, that's going to be 2y dy dx is equal to, and then the derivative 4x is just 4. So divide both sides by 2y, and I'm going to have dy dx is equal to 2 over y. So that's my first derivative. Now to find my second derivative, I'm going to take the derivative of the first derivative. So when I do that, I'm going to have, I thought this is 2 and then times y to negative 1. I would prefer to think of it that way. Then when I take the second derivative, about that later, that'll be negative 2 and then y to the negative 2, and then the derivative of y is dy dx. And then, so this will be negative 2 dy dx, and then this is over y squared. Only the items with a negative exponent go down. So this is d squared y over dx squared. Now, I'm not done because I have that derivative in here. So this is actually saying I'm taking negative 2 times the first derivative. Whoopsie, that's not highlighting. Oh, still not highlighting. So I'm going to put in the first derivative. So here I go when I do that. I'm going to say d. So I'm going to say d squared y dx squared negative 2 times 2 over y all over y squared. Well, to get rid of that y in the denominator, I'm going to multiply this by y, which means I'll multiply this by y. Here these y's will simplify. And so I am going to have negative 2, oh, sorry, negative 4. Look, I can make that a 4 over y to the third. And that's my second derivative. When you find the second derivative, you're going to have to substitute in the first derivative most of the times. I hate to say always, but I'm pretty sure it's always, but I don't know. I'm just going to say most of the time. Just look out for it. Okay, the last one. Find the points at which the graph of the equation has a vertical or horizontal tangent line. So here I have this equation. I'm hoping that you look at it and you recognize it as an ellipse because both the x and the y, x squared and y squared, are positive. So when I do this, I'm just going to take the derivative as I go. So I'm just going to say the derivative of 4x squared is 8x. The derivative of y squared is 2y dy dx. The derivative of negative 8x is negative 8. The derivative of 4y is 4. The derivative of this 4 is 0, and it's equal to 0. Oh, yell at me, yell at me, yell at me. This 4 should be dy. This 4 should be d. Oh, just a mess, just a mess. It should be plus 4 dy dx is equal to 0. If I have two y's here, I have to have two dy dx's. So I'm going to leave the dy dx's on one side. So here I'm leaving the dy dx's on the left. And I'm left with 2y plus 4. This 8x and this 8x and this negative 8, I'm going to take over to the other side. So that's going to be negative 8x plus 8. I am going to solve. So I'm going to divide both sides by 2y plus 4. So dy dx. Now I can leave it as that. I didn't. I factored out an 8, a negative 8 from here. Made this x minus 1. And I factored out a 2 here and made this y plus 2. Do you have to do that? No, but I think it's a good habit to be in, so I did. And then probably I would simplify and make this negative 4 times x minus 1 over y plus 2. If you didn't simplify it, that's fine. You don't have to simplify it. I just like simplifying it. So when the question's asking me though, when do I have vertical or horizontal tangent lines? Well, horizontal are probably the ones that you're most familiar with. Horizontal means that your tangent line has a slope of 0. So to find those ones, I'm going to say, well, this has to equal 0. Well, in order for a rational function to equal 0, the numerator has to equal 0. So for the horizontal tangent lines, I'm going to set the numerator equal to 0. So this negative 4 times x minus 1 has to equal 0, which means x is going to equal 1. So that gives me the x, but I believe, and I'm going to go back up here and verify, it wants me to find the points, which means I have to take that x, substitute it back in here to find my y. So if I do that, that'll be 4 times 1 squared plus y squared plus, oh, that's a minus, minus 8 times 1 plus 4y plus 4 is equal to 0. So this will be 4 plus y squared minus 8 plus 4y plus 4 is equal to 0. Well, the 4, negative 8, and 4 all equal 0. So I'm left with y squared plus 4y is equal to 0. I don't have to product sum because there aren't 3 terms. I am going to factor out a y and make it y plus 4 is equal to 0. And that means my y is equal to 0 or negative 4. So my horizontal tangent lines, the points where it has a horizontal tangent line are going to be 1, 0, and 1, negative 4. I'm going to have 2 of them. 1, 0, 1, negative 4. Those are the horizontal tangent lines. To find the vertical tangent lines, vertical means that the line is undefined. So if I have this rational equation, the only way it's undefined is when this is equal to 0, and the denominator is equal to 0. So that's going to happen when y is equal to negative 2. So again, I have to find the points. So I'm going back up to this equation, and I'm putting in negative 2 for my y. So I'm going to have 4x squared plus negative 2 squared minus 8x plus 4 times y plus 4 is equal to 0. I'm hoping I remember that equation, right? We'll find out. Here, when I do this, this will be 4x squared plus 4 minus 8x. Now this is times 2. So minus 8 plus 4 is equal to 0. So these equal 0. So I'm left with 4x squared minus 8x is equal to 0. Factoring out a 4x, I'm going to have x minus 2 is equal to 0. So I get the x's of 0 and 2. So my ordered pairs are going to be 0, negative 2, and 2, negative 2. So these are my vertical. So if I thought about the graph, which I don't know if any of you thought about the graph, but I thought about the graph, and then I got the graph for you. So here's the graph. It's an ellipse, and we knew it was an ellipse. The major vertices are at 1, 0, and 1, negative 4, which are the points that I just got up here. And that's going to be when my tangent line is horizontal. Then my other 2 minor vertices are going to be when at 0, negative 2, and 2, negative 2, and that's going to be when my tangent line is vertical. So did you need the graph? No, I just think it's nice that we can put it all together. All right, so I hope this helps you do some of the homework problems. I hope you're not just blindly copying from the solution manual.